Hello, my name is Mike Atkins, and this will be my third watershed assessment of Fourpole Creek. I'll be going over the NRCS assessment form and the stream classification of this section of Fourpole. So in a quick overview of this presentation, I'll be discussing the NRCS stream classification, how it works exactly, the BEHI methods, the bank erosion hazard index, the methods used to obtain the data for these classification types, and I'll be discussing the stream type. This is the stream classification worksheet that I used for the NRCS methods. If you look at the top, the first data that it requires is bank full measurements, and it asks other things like sinuosity, entrenchment ratio, channel soils, riparian vegetation, bank slope, and from that you can get a stream type, and below it takes in a pebble count. So following the stream classification worksheet, the first data is the bank full measurements, and you can see in the bottom picture a tape measure is extended to the other side, and on the top picture there is a white PVC pipe with measured increments on it, and if you look closely you can see it's right above 2 foot, and the bank full width was 36 feet. This is the specific location of Fourpole Creek that I was studying. It's close to the mouth of Fourpole. It's right on the end of Ritter Park where Kiwanis Park is. This is close to Safety Town if you happen to know where that is. But I used Google Maps to obtain this picture and get a sinuosity, which was 1.05. So for the entrenchment ratio, it's found by dividing the flood-prone width with the bank full width, which was 47 foot divided by 36 foot, comes out to be 1.3. The dominant channel soils were a reddish brown clay on both sides, and there was lots of roots sticking out too for extra protection. This will help protect it from erosion. And the actual bed materials of the stream seem to be mostly gravel, but there was a wide variety of particle types, anywhere from silt all the way to medium-sized boulders. So if you look at the left picture, that's the right bank, and on the right picture, that is actually the left bank. And you can see that there is lots of roots located without it. But for the right bank, the total area covered by vegetation in the riparian area was about 90%, and the total height with the roots was about 90%. And in lots of places, it looked like it was about 100%. On the left bank, the roots were about the same, at about 90%, but the total area of the riparian vegetation being covered was cut down to at least 60%, because on the left bank side is actually the park side where people are walking through, so a lot of vegetation's been cut down. But on the right bank is on the edge of a hill with it's heavily forested. And here's a better picture of the left bank where you can see right on the top it's been cleared out. So for the slope of the left bank was about 0.83, and the right bank was about 0.8. The stream slope elevations were obtained from Google Earth, and the stream slope seemed to be about 0.009. So if you look at the level 1 classification, and consider the slope of the stream, which was right under 1%. It should fall into the category C, but I'm thinking there were some errors in finding the slope because B looks almost exactly like the channel form. And so the valley type for this section of Fourpole Creek, I believe, would be the first one in the picture, VII, because it is steep and has highly dissected fluvial slopes. So taking into account all of the data obtained, we can go to the third level of the stream classification. And the first thing we want to do is find our entrenchment ratio, which was 1.3, so it's moderately entrenched. And if you move down, the width to depth ratio was 17.1, which is larger than 12, so we can move down to sinuosity. And we got 1.05 for sinuosity. And it's supposed to be greater than 1.2, but for sinuosity, you can plus or minus several units. So moving down even further into stream type, we get B. The slope range is the far right one, less than 0.02. So then we go down to the channel material, which was mainly gravel. So that would make it B4C. Here's an Excel file summarizing my pebble count data. If you look down at the bottom, overall composition, you'll notice that it is almost 50-50 between fine gravel and coarse gravel. So gravel is definitely the dominant bed material. So now getting into the BEHI field form, it includes 5 different metrics. The first one being bank height, then root depth, root density, surface protection, bank angle. Then we go down to material adjustment, depending on what your bed material would be. Mine would be gravel. Then you got stratification adjustment, and then you can find your total score to find out the category of bank erosional hazard index that you're in. So for the first metric is the ratio of bank height to bank full height. That score gave us 1.5. Second one was ratio of root depth to bank height, and roots extended down 6 foot of a 6 foot tall bank, so that was 100%. Root density in percent was about 80%. Bank angle was estimated to be about 135 degrees. Surface protection was about 80%. Material adjustment was mostly gravel, so we add 5 to our score. There was no stratification adjustment. So adding all these scores together gives us 23. And if you look down in the category that's in moderate, our bank erosional hazard index has found this part of Fourpole to be moderately eroded. So here's some extra pictures of my site that I was sampling. If you look on the left, that's actually the downstream view, and on the right is the upstream view. And here's a better picture of the channel bed materials. The left picture is on the left bank, and the right is on the right side by a riffle. And you can see that it's mostly all gravel. There's also large boulders and random cinder blocks in this stream too.